Hi guys, this is AS Chemistry, Balancing Equations, question 1. Granular urea CON2H4 can be used to remove NO2 from the flue gases of power stations, converting it into harmless nitrogen. And the reaction equation is given. What are the values of X, Y, and Z in a balanced equation? So, X is the number of moles of NO2 gas. Since NO2 consists of two different atoms and the total number of atoms present is 3, we cannot have a fraction representing the value of X. So that eliminates option A automatically because of 1.5 representing X. So for option B, if we have 2 moles of NO2, so that makes a total of 4 and 2, 6 moles of nitrogen on the left. And according to this, we have 3 moles of nitrogen on the right. So that is 6 moles of nitrogen. So the number of moles of nitrogen is balanced. So now we balance the other elements. So this is 4 for Y. So nitrogen we have 6 on the left, nitrogen we have 6 on the right. And for carbon, we don't need to balance carbon because carbon is 2 on each side and that is fixed. The value is not even changing for the molar ratio. So for hydrogen, we have a total of 4 to the 8 hydrogen on the left and Y is 4, so 4 to the 8, so 8 hydrogens on the right. So that is also balanced. Now for oxygen, we have 2 and 2 to the 4, total 6 oxygen on the left, and on the right we have got 4 plus 4, 8 oxygen on the right. Because of inconsistency in the atoms of oxygen present, option B gets eliminated. Now moving on to option C, we have uh, X represented by 3, Y represented by 4, and Z represented by 3.5, which is possible because we've got half a molecule of nitrogen, which is one atom of nitrogen. So in this case, nitrogen on the left would be 3 and 4, 7. Nitrogen on the right would be 3.5 into 2, which is also 7. So nitrogen is balanced. For hydrogen, we've got 8 hydrogen on the left, and on the right, we've got 4 to the 8 hydrogen on the right. So hydrogen is also balanced. And for oxygen on the left, we have 3 to the 6 plus 2, 8 oxygen on the left. And on the right, we've got 4 and 4, total of 8 oxygen on the right. And since we've already discussed that carbon is balanced, 2 on each side, so this makes option C the correct option for this question. Question 2. In the following equations, the letter W, X, Y, and Z all represent whole numbers. When correctly balanced, which equation requires one of the letters W, X, Y, or Z to be 5? So let's start with C3H7 COOH. So this would be in total C4, H would be 8, and O2. So in order to balance this, we use the general combustion equation, x plus y upon 4. So 4 plus 8 upon 4. 8 upon 4 is 2. 4 plus 2 is 6. And we've got one molecule of oxygen present in the compound itself. So 6 minus 1 is 5. So we end up with 5O2, giving us 4 CO2 and 4 H2O. So only in the first option we have obtained a value of 5 for X, which is the number of moles of oxygen, making option A the correct option for this question. Question 3. Arsenic chloride AsCl3 reacts with sodium borohydride. The equation is given. What are the numbers P, Q, R, S, and T when this equation is balanced correctly? So in order to do this, we should use each of the options and tally the number of atoms present. So for option A, we've got 2 for P, 3 for Q, 2 for R, 3 for S, and 1 for T. So we have got the elements AS on both sides. We've got chlorine on both sides. We've got sodium on both sides. We've got boron on both sides, and we've got hydrogen on both sides. So one by one, we are going to tally the number of each of these elements and see which equation gives us the correct balanced number of atoms. So for AS on the left, we've got 2, and on the right also we've got 2. So this is balanced. For chlorine on the left, we've got 6 atoms of chlorine. On the right, we've got 3 and 3, 6 atoms of chlorine. For sodium on the left, we've got 3 atoms of sodium. On the right, we've got 3 atoms of sodium. For boron, we've got 3 atoms of boron on the left and 1 atom of boron on the right. So there is an inconsistency with the number of boron atoms. For hydrogen, we've got 4 threes are 12 hydrogen on the left, and on the right, we've got 3 twos are 6 hydrogen on the right. So hydrogen atoms are also inconsistent, eliminating option A. Moving on to option B, we've got values of 3 for P, 3 for Q, 3 for R, 3 for S, and 2 for T. So now let's see. The number of arsenic would be 3 on the left and 3 on the right, balanced. Number of chlorine would be 6 on the left and 3 to the 6 on the right, plus 3 NaCl chlorine atoms. So that makes it 9. So there is inconsistency with chlorine. In fact, there was inconsistency with chlorine even before with option A, which we missed, because there are two compounds having chlorine atoms. It is NaCl and BCl3. So on the left, we had 6 atoms of chlorine as we had written, but on the right we just looked at BCl3 making it 6, but NaCl also had 3, so 6 plus 3 9. So this was not 6, this was 9. So even chlorine was inconsistent in option A. So option B also becomes inconsistent, eliminating option B. We are moving on to option C now. For option C, we've got 4 uh, as a value for P, as a molar ratio of P. For Q, it would be 3. For R, it would be 4. For S, it would be 3. And for T, it would also be 3. So let's total the number of each element on each side. So for arsenic, it would be 4 on the left and 4 on the right, which is consistent. For chlorine, it would be 4. So these are 12 on the left, and on the right, it would be 3 plus 9, which is also 12, which makes it consistent. For sodium, it would be 3 on the left and 3 on the right. For boron, it would be 3 on the left and 3 on the right. And for hydrogen, it would be 4 threes are 12 on the left, and on the right, it would be 4 threes are 12 on the right. So for option C, all of the given molar ratios correspond to consistency with the number of each element on both sides of the equation, making option C the correct option for this question. Question 4. When copper reacts with a 50% solution of nitric acid, nitrogen monoxide is evolved and a blue solution results. The balance equation for this reaction is shown. What are the values of the integers p, q, r, s, and t? So here we have to balance the number of atoms on each side of the equation. So we've got copper on both sides, we've got hydrogen on both sides, we've got nitrogen on both sides, and we've got oxygen on both sides. So one by one, let's place the values as given in the option. So if P is 1, which makes copper 1 on the left, and R is 1, so which makes copper 1 on the right. So for hydrogen, the value of Q is 4. So we've got 4 hydrogen on the left, and on the right, we've got a value of 3 for S, where hydrogen is present. So 3 to the 6. We've got 6 hydrogen on the right. So that makes the balancing of the number of atoms on each side inconsistent, eliminating option A. Moving on to option B, we have 2 copper on the left and 2 copper on the right. So this is balanced. For hydrogen, Q is 6. So 6 hydrogen on the left. And for hydrogen, we've got 3 for S. So 3 to the 6, 6 on the right. So hydrogen is also balanced. Moving on to nitrogen. So Q was 6. So 6 nitrogen on the left. And on the right, we need two values, R and T. So R would be 2. So 2 to the 4, 4 nitrogen with respect to R, and with respect to T, we've got 2. So in total, 6 nitrogen atoms. So nitrogen is also balanced here. For oxygen on the left, we've got a value of Q to be 6. So 6 threes are 18. 18 oxygen on the left. On the right, the value of R is 2. So 3 to the 6 and 2 12. 12 oxygen with respect to R. With respect to S, the value is 3. So 12 plus 3 is 15. And with respect to T, the value is 2. So 15 plus 2 is 17, making the number of oxygen atoms inconsistent. So this eliminates option B. For option C, we've got a value of copper to be 2, and R is also 2, so copper is 2 on the right as well. Copper is balanced. For hydrogen, we've got a value of 8 for the left side of the equation, and for the right side of the equation, the value of S is 4, so 4 to the 8. So hydrogen is balanced here as well. For nitrogen, we've got a value of 8 for the number of nitrogens on the left, and on the right, we've got a value of 2 for R, so that makes 2 to the 4, 4 hydrogen with 4 nitrogen with respect to R, and T is also 4, so that makes it 8 as well. So nitrogen is also consistent on each side. Now we are left with oxygen. So number of oxygen on the left would be 8 threes are 24. And on the right it would be 3 to the 6, and 6 into 2 is 12. 12 with respect to R. With respect to S, it is 4. 12 plus 4 is 16. With respect to T, it is also 4. 16 plus 4 is 20. So oxygen is inconsistent in option C as well. So this leaves us with option D, which has to be the correct option, but we will tally the number of each atom as given in the option just to be 100% sure. So here we've got 3 copper on the left and 3 copper on the right. For hydrogen, we've got a value of 8. So 8 hydrogen on the left, and on the right, S is 4, 4 to the 8, 8 on the right. For nitrogen on the left, we've got a value of 8 for Q. So 8 hydrogen, 8 nitrogen on the left, and on the right, the value of R is 3. So 3 to the 6, and the value of T is 2. 6 plus 2 is 8. 8 on the right as well. So nitrogen is also consistent. Now for oxygen. Q is 8. 8 threes are 24. For the left, for the right, R is 3. So 3 to the 6, 6 threes are 18. 18 plus S is 4, so 18 plus 4 is 22, and T is 2, so 22 plus 2 is 24. So in option D, all the four elements are consistently balanced on both sides of the equation, making option D the correct option for this question. Question 5. In the steel making process, the P4O10 impurity is removed by reacting it with calcium oxide. The only product of this reaction is the salt calcium phosphate. In this reaction, how many moles of calcium oxide react with 1 mole of P4O10? So CaO is calcium oxide, P4O10 is the impurity that reacts with it, and the product is Ca3PO4 twice. So in total, we've got 2 moles of phosphorus here and 4 moles here. In order to balance the number of moles of phosphorus, we multiply this compound with a molar ratio of 2, making phosphorus 4 on each side. So when we have got 4 of phosphorus, now we need to check for oxygen. So we've got 10 oxygen with respect to P4O10. And on the right, we've got 4 to the 8, 8 to the 16. So 16 minus 10 gives us a value of 6. So we need 6 more oxygen. So we need to place a molar ratio of 6 over here. But then again, we have to check for calcium. If there are 6 calcium on the left, there should be 6 calcium on the right as well. So 2 3s are 6. So that actually balances out. So the number of moles of calcium oxide required by balancing this equation is 6 moles, making option D the correct option for this question. Question 6. In a famous experiment, Wohler heated inorganic ammonium cyanate in the absence of air. The only product of the reaction was organic urea. No other products were formed in the reaction. What is the formula of the cyanate ion present in ammonium cyanate? So we've got the product as CONH2 twice, and the reactant is an ammonium salt. So if we've got an ammonium salt as the reactant, so that would be NH4 positive. So because we've got NH4 positive, so we would be needing an anion with a charge of -1. And in order to balance the number of nitrogen and hydrogen atoms, let's total them. So on the right, we've got 1 carbon, 1 oxygen, 2 nitrogen, and 4 hydrogen. On the left, we've got 1 nitrogen and 4 hydrogen. So what are we left with? 1 carbon, 1 oxygen, and 1 nitrogen. So C, N, and O. So that eliminates options C and D. We need C, N, and O. And in order to balance the charges, ammonium ion has a charge of +1. So the cyanate ion will have a charge of -1, eliminating option B, making option A the correct option for this question. Question 7. Aluminum carbide Al4C3 reacts slowly with aqueous sodium hydroxide. The two products of the reaction are NaAlO2 and a hydrocarbon. Water molecules are also involved as reactants. What is the formula of the hydrocarbon? So let's balance this equation. We've got Al4C3 on the left reacting with NaOH and H2O. These are the reactants. The products are NaAlO2 plus a hydrocarbon. So the hydrocarbon contains 3 carbon atoms because we've got only 3 carbon atoms on the left. Now let's balance the rest of the equation. So in order to balance the rest of the equation, we've got 4 aluminum here. So this would become 4, which makes 4 sodium here. So this would also become 4. So now, in order to balance the oxygen and hydrogen, So we don't know how many hydrogen are present in the product side. So only oxygen is left. So oxygen would be 4 to the 8. 8 would mean 4 oxygen are present in NaOH and 4 would be present in water. So that gives us the total number of hydrogen on the left, that is 4 with respect to NaOH and 8 with respect to H2O. So in total, we've got H12, but there is no compound with the formula of C3H12, but this gives us a total number of carbon and hydrogen atoms present. So we've got 3 carbon and 12 hydrogen atoms present. So in option A, we've got 1 carbon and 4 hydrogen. In option B, we've got 2 carbon and 6 hydrogen. In option C, we've got 3 carbon and 8 hydrogen. In option D, we've got 6 carbon and 12 hydrogen. So if we think carefully, in order to obtain 3 carbon and 12 hydrogen, if we multiply the option given in A, CH4 by 3, we end up with 3 carbon and 12 hydrogen atoms. That means the formula for the hydrocarbon is not C3H12, it is rather 3 moles of CH4, making option A the correct option for this question. Question 8. When lead 2 sulfide is heated in air, sulfur dioxide and lead 2 oxide are formed. What is the equation for the reaction between PbS and oxygen? So the reactants are PbS and X number of moles of oxygen producing lead 2 oxide, which is PbO, and sulfur dioxide, which is SO2. So in total, we've got 1 mole of lead on each side, 1 mole of sulfur on each side. We've got 3 atoms of oxygen on the right. So in order to balance that, we need 3 atoms of oxygen on the left, making the molar ratio 1.5 O2. So 1 mole of PbS, 1.5 moles of O2, 1 mole of SO2 and 1 mole of PbO. This makes option C the correct option for this question.